All right, well, thank you all for being here on a Saturday to learn about exceptions after another talk that was about exceptions earlier. So who was at Simon's talk earlier? Okay, so there's going to be a little bit of overlap, but we're going to look at a few different things through other lenses, so it should be okay. And then was anybody at my workshop on Thursday? A couple people? All right, cool. All right, so write less code, fail elegantly. So we're going to kind of dive right into it. I'm pretty sure you've all done some validations before, right? Some input comes in, you want to validate through a bunch of rules. And the code might look a little bit like this. If you put like an if block with a bunch of validation rules, and you hope that each validation method is going to return true. And if each one returns true, then we might do some transaction and then return true to signal that the transaction was successful, right? That might be a way to do it. And then if any of those things return false, then we might just kind of return false. And then, so whatever is upstream of this code has to handle either true or false, right? On top of you having to write these methods. So in this model, these validating methods might look a little bit like this. If some error happens, then return false, else return true. Now you could just reduce the amount of lines here and just say if not some error condition, or return not some error condition. But sometimes it's a little bit kind of hard to read. But that's one way to do it, right? So you would do that for validate thing one. Same thing for the next method, same thing for the next method. And that's, by and large, it's pretty okay. The thing is, each validation method must return true or false and to signal the success or the failure. And then the upstream methods must adapt their behavior based on what was returned. And so the code does have more nesting. Hadouken! Right? So I've come across a lot of code like this. It's not great. All right, so another way to do it by leveraging exceptions might look like this. So in this case, we don't have any if-else. We're just going to have three method calls, which are going to be gating method calls. So if any exception is thrown above, then what's here, do some transaction, is not going to return. It is not going to execute. Okay, it's not going to run. And you could, of course, put all these three methods in a consolidated validate everything method, of course, right? So now each method kind of looks like this, and it's a lot easier to read because your if statement now becomes on the error condition that might happen, right? So if something bad happened, then throw a invalid thing exception. So here's for 2, and then here's for 3. So it does keep your code a lot flatter. And your validation methods don't need to return anything. All they have to do is throw if something bad happens. So now what's nice about this, and we're going to look at a little bit how exceptions kind of flow upstream, but the nice thing about it is that upstream methods don't have to care. And the code is going to have a lot less nesting. So let's look at another use case, which is kind of more realistic if you deal with web applications. Let's say we're building a web service, an API endpoint that says get products for user. There are two possible failure modes. One, the user has no products. That's okay. Another one is, well, what happened if I passed the wrong user, right? What happened if the user was not found? That's not normal, right? If I say get products for user and I gave you the wrong user ID, something's wrong there, okay? So a possible architectural stack to make this happen, you might have your controller at the top with a method called getProducts to which you pass an integer user ID. And then just below it, you may have a service class that says getProductsForUser to which you pass the user ID. And so now that getProductsForUser method will return an array. An array of what? An array of products. If we had generics, that'd be nice because we could actually say that, but we can't. So below the service, what we might do is have a user repository that will allow me to retrieve the user by ID, right? Because here I'm just passing a user ID, and so I might want to retrieve the user by ID to get an actual user object right here. So right next to this call, then I can call a product repository getProducts method to which I can pass that user object. Could be one way to do it. And so then that getProducts method on the repository will return the array, which will then get returned here, and which will return by the getProducts. I should have put colon array here as well. Okay. So let's look at this user repository getUserById, which is supposed to return an instance of a user object. So this is what it could look like in Doctrine, where we call the getSingleResult method. So we pass the user ID here, and we make a little DQL to retrieve the user by ID based on the past user ID. So yeah, the question is, what if this user ID is bogus? What happens when user not found? This is the ultimate user not found when you're cast away. So there are a few things that we could do, right? If no user was found, we could return null, we could return false, we could return -1, right? I mean, we laugh, but I've seen this in code that I manage, so so this is what it would look like, right? Even though Doctrine will actually throw an exception for me, right? I'm going to cache that exception, and I'm actually going to go out of my way to return null, right? I'm just going to, object-oriented be danged. Yeah, so return null. Awesome. So just above the repository, we have our product service. Now that product service obviously has to handle this is null condition. So then you have a choice to make, right? If my user is null, what do I do? Well, to me, the laziest thing I can think of is to return an empty array, right? I'm trying to get products for user, could not find the user, I still want to return an array, so I'm just going to return an empty array. So if no user is found, I return an empty array of products because it feels convenient. Is this, however, elegant, right? Remember, you're building an API, right? Think about the feelings of the person who's using your API right now, right? They accidentally put the wrong user ID, and they keep trying. And I'm like, I did put products in this user's basket, and I keep getting no products, right? People start hating me if I do that, and I don't want to be hated. But let's explore it. So an empty array of products will be returned if it's the correct user, but they actually have no products. So that's legitimate. But it will also, if no user was found, right, in both those cases. So yeah, that's okay. That's not okay. All right. Strange behavior. So there is an alternative that I could have, right? If my user is null, instead of returning an empty array, I could return -1, right? So now I'm signaling that, -1 is a magic number that's there to signal that something was wrong, It's like a shell script. So yeah, I'm using -1 to signal the user was found. And so then it gets fun. It gets really fun because, PHP is totally cool with that, right? That I can either return -1 or, return an array of products and have inconsistent return types. Now, if you're using a static analyzer, if you're using an IDE, the IDE is going to be like, don't do that. But technically, you can. So yeah, I return -1 to signal that user could be found. So now my service can either return an array of products or -1, right? I have those two possible return types. And we're going to see that it's not great. I'm just saying it's not great, but I'm going to try to demonstrate it. Because it has an impact upstream, right? So if the service now returns either if the service returns an array or -1, then what's just upstream of it, which is the products controller, it has to handle that condition, right? So now the controller has two options. The controller could just also decide to always return an array, just kind of double down on what the service is doing. Or option number 2, the controller could actually try to handle this -1 condition. So let's look at both options. Let's look at option number 1, which is the laziest option, where the controller always returns an array. Wait, I'm going to show the code later, sorry. And then option 2, the product service, the products controller now can handle that special case. So we're going to look at the code for both cases. So let's look at option 1 now. That's it, right? So if the product service returns an array, I can just let the products controller just return what the service returns and then be good with it, right? Now, of course, the API consumer is going to be confused because I'm always returning an array even if the user is not found, so that's not great. Now, option number 2, the controller has to handle this condition now, right? So if products, instead of being an array now, is -1, then I might, send an error message, bad user ID. So at least in this case, I am handling this error condition. So somebody using my API will not be confused. And then if I did get an array, if it's not -1, I'm just going to return the products, assuming that it's going to be an array. Okay? So the pros, at least we don't confuse the API consumers when they send a bad user ID. The cons, it's a lot more code. And now you're kind of mixing user-related code with products-related code. And the controller has to know what this magic number -1 means, right? So it's not great. So it has some impacts, obviously. If you think about it, your user repository could be used by dozens of services, each of which is going to have to handle this null condition and in turn find a way to signal this upstream to the controller who happens to be using that service, with a -1 value, and then the controllers will have to handle -1, right? So you can see the ramifications throughout the code base that can happen with kind of this model every time. So now that we just looked at one repository having an impact on multiple services and multiple controllers, but obviously you're going to have more than one repository in your code base, right? You could have dozens of repositories. Things don't get fun. So obviously you get rampant status codes, and they could signal any number of error conditions. And of course, you always want to find some way to bind those error codes to helpful messages, right, for end users. And what you might do is maintain them in lookup arrays, and some like global array that maps error codes to messages. Oops, sorry. Bam, okay. So yeah, so much code, and when that happens, corners are going to get caught, right? These error conditions are just not going to get handled, and then strange behavior is going to creep throughout the system for sure. And so this is where exceptions can really help us. As DJ Khaled famously said, the key is that exceptions are king. He likes to win, so. All right, so remember this repository that we had where we were returning null. Well, what we could try to do here is, instead of returning null, we could throw a new UserNotFoundException to which we pass the user ID. So when that happens, so that's the exception. That's kind of what it could look like. So in the constructor, I'm passing the user ID, and then I feed the user ID to a message. The message should really say, oh yeah, I have the constant message, user could not be found, : and then I append the user ID. Notice that little inval that I put in there. In Simon's talk earlier, we kind of talked about echoing user input. Remember that an exception could be presented into a user screen, right? So somebody could try to do a cross-site scripting vulnerability on there. Also, an exception could show in a log on your terminal in a console. Somebody could put escape characters in there, right? So you want to try and have some sanitation if you are going to echo something that was passed into the program, okay? So the nice thing about the exceptions flow is it kind of looks like this. So here's the stack, the architectural stack that we had, right? We have the controller. Below the controller, we have the service. And below the service, we have our two repositories. But specifically, we have the user repository, which throws a UserNotFoundException. So when that happens, it's going to bubble all the way up to the top. And if nothing catches it, then if it's a RESTful endpoint, it'll show as part of the REST output. So you always want to make sure that you don't leak sensitive information in your exceptions, right? But the nice thing is you can see that the name of my exception tells me exactly what happened. And we're going to look a little bit, we're going to look at that a little bit more. So yeah, no code has to catch it, and the framework can output it in a useful way. So now that we have an exception being thrown, we can simplify our code pretty dramatically, right? So this is our user repository where we actually throw an exception. So now let's look at the impact upstream, right? The above the user repository, we have the product service, which used to look like this, right? Where we had this null check. So we can get rid of that. Okay, now the code is simply, more simple. And now I can simplify this line here, boom, and that's it. Now I'm down to 2 lines of code, right? And again, I'm fully handling something going wrong because that UserNotFoundException is going to get thrown. So now let's look upstream of the service. Let's look at the controller. Remember all this code that we wrote here. Let's make that go away. Boom. And now let's just compact that more. Boom. There you go. So now again, we're down to effectively 1 line, right? So it's a lot simpler. Yes. So, as you can see, you start seeing some benefits for exceptions. One, it's less code to handle those error cases. And now you can also localize signaling at the component level, right? So whenever you have a piece of code that may end up in an error condition, you can just focus on that piece of code and having it throw an exception that is relevant to this component that you're working on, right? And then you just leave it up to something upstream to kind of handle it or decide to handle it or not, right? But it gives them a lot more information. So you can really focus, something goes wrong in my world, I throw an exception that's relevant to my world, okay? And you can have a lot more information, right? The name of the class itself tells you almost everything you want to do. The message that you can pass in the constructor gives you more information as well. There are some more properties that you can add to exceptions as well if you really want to. And the nice thing about it is it gives you more decoupling between signaling and handling. So when you return null and you return -1, anything that's upstream of you must handle that, right? It's just otherwise, the code is not going to function. With exceptions, you don't have to catch them if they're not relevant enough for you to catch, and you can let them bubble up. So over the years, I've identified some best practices. In Simon's talk, he kind of went over how to name exception classes. I like how he handled it. One of the things that he mentioned was to not put the word exception in an exception class name. I like that. I didn't think of that, but I think it's a good idea. But some other things that that I think about is I definitely want to catch ORM exceptions and rethrow my own. Now, if you were at my workshop a couple days ago, I literally did none of that. Didn't have time. But you really want to catch those ORM exceptions for several reasons. One, you want to avoid leaking sensitive information. Remember, your ORM interacts with your data store. I want to assume that Doctrine is going to do the right thing and never leak any credential information, but I just don't want to assume it. Okay, so I like to rethrow my own exception. I do like making lots of custom exception classes for some definition of lots. And this is where you can think of a taxonomy a little bit, a hierarchy. Because exceptions can extend another exception, which can extend another exception. And you can build a hierarchy. And we're going to look at it gives you more options to catch exceptions at different levels of the hierarchy based on what's relevant. We're going to look a little bit at kind of the layered catch statements and what you can do with those later on. So I try to avoid reusing the same exception with different error messages. If I'm using the same exception with different error messages, it may signal that I have, in fact, two different exceptions that I should have. Not in all cases. If it's really closely related, then maybe not. But it's something to think of. Try to embed the messaging inside of the exception, and yes, name them as specifically as possible. So in Simon's talk, he kind of showed kind of patterns to think about for naming an exception, where it shows you, it kind of conveys the cause of what went wrong. It tells you what went wrong and why it went wrong. I think it's a good thing to keep in mind. All right, and then like I mentioned earlier, try to escape or cast inputs, right? If your exception is going to capture like a user ID, remember that somebody could have put anything in the request as that user ID. They could try to be compromising your system. So that's why I was doing inval on user ID, but you could do something else as well. So now we're going to look at catching polymorphic exceptions, because I just talked a little bit about kind of having a class hierarchy on your exceptions to give yourself more options. As an example, we're going to look at the Doctrine ORM. Anybody here uses Doctrine? Okay, cool. So in this code example that I had, I was calling this method called getSingleResult, right? So there's a contract here that says whatever query you gave me here must return a single result, and I will return exactly what that result is. So if you think about it, there are two possible error conditions. One, no result was found, right? That user ID was not found. The other one is I'm getting more than one result. Now, if you get more than one result based on the user ID, you do have a lot of problems in your data schema, but anything's possible, right? This is kind of why the ORM has those two exceptions. So this is some of the source code for getSingleResult inside of the Doctrine ORM. So this is getSingleResult, and you can see that here it will throw that no result exception, and then here it will throw that non-unique result exception. So for those two error cases, Doctrine can return a no result exception or a non-unique result exception. Okay? So if you look at the class hierarchy, you have PHP's exception class, and their base exception class is called ORM exception. And below it, they have unexpected result exception. And an unexpected result exception can be one of two. It can be a non-unique result exception or a no result exception, right? So that's kind of how they've layered the code. So this hierarchy allows me to catch an exception at any of those levels, right? I can be lazy and say catch exception, then I have no idea what it is that I'm catching. But I can be very specific and literally try to catch that and kind of handle that specific case. But maybe I just want to catch an ORM exception because my code doesn't really care. It just only cares about the fact that it's an ORM exception, right? This is the flexibility that a class hierarchy gives you. So when you ask yourself, should I make a lot of specific exception classes or should I make more generic classes? I'd say you can have both. It may just be tedious to create a lot of specific exception classes. But if you feel like doing it, make sure that they extend something that's kind of more generic, because then you can catch something that's more generic and gives you more flexibility. So an example of this is so what we're going to see here is what happens where, I can use fallback mechanism. So I can catch no result exception, and then as a fallback, I can catch this. As a fallback, I can catch ORM exception. So we're going to see what it looks like. So I can catch a no result exception with specific handling of a no result. And then as a fallback, I can catch an unexpected result exception. There are two types of unexpected result. One is this one, which we're explicitly catching, which is no result exception. The other one is non-unique, right? I'm not catching non-unique. I only care really about this one. And then any other type of unexpected, I'm just going to handle this generically, right? So this is a way for me to catch anything that's an unexpected result exception that's not this one. Okay, and then below it, again, I can fall back. I will catch any ORM exception that is not an unexpected result exception. Okay? So an example of what I could do is I could catch no result exception like we did earlier and throw my own exception, which is new UserNotFoundException. So then I could catch any other error and I could just log it. Now here I'm only logging it. I should also throw something, right? So it's kind of an incomplete example. If you have a method that returns something, it should always return that thing or throw some kind of exceptions, right? You don't want to just catch something and then have it end here. And then I can catch an ORM exception and log it. So again, I should have my own kind of generic exception that I throw back up. Okay, so in this example that we had earlier, I can add a catch block. And then this is kind of what I did here. So I can catch an unexpected result exception, log it, and then throw my own exception called unexpected application exception. Okay. So now I can catch exceptions with pipes. This is, so it's useful when you're trying to catch multiple types of exceptions that don't have a common ancestor. So this is an example of using a pipe. In this catch block, I will catch either a no result exception or a non-unique exception. Now, because each one of these exceptions actually do have a common ancestor, it's more efficient to just do a catch on the common ancestor, but this is an example, right? So if these were just two completely different exceptions, then I could just catch them both with a single statement. All right. PHPUnit. So if you're doing some kind of test-driven development, does anybody here do test-driven development? I know Jessica does. That's what's up. Yeah. Cool. All right. What you do is you declare what comes. What you do in the PHPUnit is you're going to declare that what comes next is about to throw an exception, and then you trigger the exception throwing behavior. And it kind of looks like this. Let's say I have a bogus user ID. You know what those numbers are? 4, 8, 15, 16, 23, 42. Is that from Lost? Yeah. Execute, right? So you create a bogus user ID. Then you say, I'm about to expect an exception, a UserNotFoundException. And then I trigger the behavior where I call my UserRepository getUserById. Okay? So I am signaling that exception will be thrown, and then I am triggering the exception, and then my test will pass. Let's do quick live coding. I'll show you that example. What could possibly go wrong? All right, let me mirror my screen. That was my dog and my daughter. Okay, let me mirror the built-in retina display. Okay. So for those of you that were in my workshop a couple days ago, we created a way to create a user in the repository and then retrieve it by ID. This method here will give me a user that is saved to my data store. So I'm going to say good user equals this. So then I'll create an instance of a rogue user, which is going to be an instance of my app user entity, to which I'm going to pass first name rogue, last name user. Okay, so good user's user ID actually does exist in the database, because this is what getRepoNoUser does, right? It creates a user and saves it. But rogue user, I just created my entity out of nowhere, so it does not exist in my data store. So then I want to say this expect exception user not found. I'll say user was not found, and I'm going to do what Simon said, which was to not put the word exception in my class. So boom. And then I'm going to trigger the behavior that will throw an exception. So by ID, rogue user's ID. Okay. My app user entity uses UUID. So whenever I create an instance of it, its ID will be a UUID 4, based on Ben Ramsey's UUID package. Okay. So now I'm going to run my test, and it's going to fail because it says that this class does not exist. So let's just make it exist real quick. I'm going to go up to my project, back down into app bundle exception, put it with its friends right here. I'm going to move it to the right. And then I'm going to say app bundle exception, and I'm going to extend the exception class. Ooh. Okay. And that's really all I'm going to do for now. I think that's enough. So now that my class exists, I'm going to import it in my test. Import class, boom, done. So I'm going to run my test again. And it's going to complain that what I'm getting is a doctrine ORM no result exception, right? And what I'm looking for is a user was not found exception. Okay, so let's inspect this. I'm going to look at that byId method, which is my interface. So I'm going to go back down to the implementation right here. And as you can see, I am literally not handling any kind of exception in my in my doctrine query, right? I have those throws annotations, which is just me ignoring what my IDE is telling me that I should be handling this. So I'm going to remove this. And now I'm going to do surround with try catch. Here we go. And you can see that this no result exception is what's being, what can be thrown by getSingleResult. So for now, I will comment out non-unique result exception because I don't care about it. Technically, I should handle it, but all right. And then I'm going to go throw new user not found. New user was not found. Here we go. Okay, so now my byId method can throw user was not found. Okay, so if I pass it a bogus user ID, then this exception should be thrown as I am expecting it here. As I am expecting it here. I mean, there you go, right here. So, is my test going to pass? Yes, no? Yes, it will. Boom, it passes. We're good. We're done. Win. All right, so back to the presentation. Separate display. Boom. So that was, the code. So if you're interested in TDD, I do have a lot of, if you want to put yourself to sleep or put your kids to sleep, I have like 7 hours of video on YouTube. It's kind of like the workshop, except that what's on YouTube does not go to the acceptance level. The workshop that we did a couple days ago does, and the video that I gave you on the disk actually does go to the acceptance layer as well. All right, so takeaways. The idea is to fail with poise, signal failure with less code, handle failures with less code, reduce technical debt, build more robust systems. Exceptions as your friend are your friend. That's all I had to say about that. Thank you.